Hi everyone, welcome to GeoSet. Today I will discuss Isohyetal method for determining the average depth of rainfall, which is one of the three types of average depth analysis. I have already discussed the arithmetic and Thyssen polygon methods earlier. The link of these videos are provided in the description. The Isohyetal method is considered the most accurate compared to the other two methods, and each generally used for large areas to reduce the effects of rainfall variability. Here, we give weightage to the rainfall to reduce the effects of rainfall variability, and the weightage is based on the area. In the Thyssen method, the area is divided by drawing polygons based on the rain gauges and assuming uniform rainfall within the each polygon, and the weightage is area multiplied by polygon. For example, the weightage of polygon D is the rainfall of station D multiplied by the area of polygon. In the isohyetal method, the area is divided by drawing lines of equal rainfall, that means isohyets, to represent more detailed spatial variation of rainfall. So in this method, we don't give weightage to each station, give weightage to the average rainfall between isohyets. This means the average rainfall between two isohyets multiplied by the area between two same isohyets. So the weightage is average rainfall between the two isohyets multiplied by area between these two same isohyets. For example, the weightage between these two isohyets is the average rainfall between these two isohyets multiplied by the area between them. Here we calculate average depth of rainfall by drawing isohyets. That's why it is called the isohyetal method. The formula of this method follows the weighted mean formula. Here it is. PAV is the average depth of rainfall in a particular region in a particular time period. P1 is the average rainfall of zone 1. That means average rainfall of first two isohyets. And A1 is the area of zone 1. That means area between first two isohyets. This continue up to the nth zone. Simply we can write this formula as summation of P into A divided by summation of A. Let's draw the isohyets, which is the main part of this method. The following points outline the procedures to draw isohyet. First point is that collect the data from different rain gauge stations. That means collect the weather station data from each station within the area of interest and assign to each weather station. After that, plot minimum 4 isohyet lines at equal interval. You can plot more than 4 isohyets, but not less than 4 isohyets. Greater number of isohyets generally reduce the variability of rainfall in each zone and increase the accuracy. So let's calculate the average depth of rainfall. For practice, I am going to calculate average depth of rainfall with 3 isohyets. Here are 4 weather stations. You can see weather station P1, P2, P3 and P4, and the rainfall of the station is 8, 13, 17 and 22, and 3 isohyets are 10, 15 and 20. So after drawing the isohyets, we obtained 4 zones. This is zone 1. Here rainfall is less than 10. This is zone 2. Rainfall is between 10 to 15. This is zone 3. Rainfall is between 15 to 20. And this is zone 4. Rainfall is greater than 20. So after drawing the 4 isohyets, we get 4 zones, 1, 2, 3 and 4, and the isohyetal value of each zone and the average value of isohyets, which is calculated as a lower class limit plus upper class limit divided by 2. So here it is 10 plus 15 divided by 2, 12.50. 15 plus 20 divided by 2, 17.50. But for first class, 5 plus 10 divided by 2, 5 because of the class interval is 5. Here for last zone, 20 plus 25, we have taken 25 because class interval is 5. So these are the areas. You can calculate the area of each zone using the graph paper or using the planimeter. Now, according to the formula, multiply the rainfall by its area. That means A multiply by B. 7.50 multiplied by 8. In this way, up to the last zone. You can also calculate the area weighted rainfall of each station by dividing A into B of each station by the total area. Here it is A into P divided by total area. That means 60 divided by 33, 112.50 divided by 33. If we sum up the area weighted rainfall, we get the average depth of rainfall, 14.62. Also, according to the formula, sum of A into P, that means 482.50 divided by summation of A, we also get the average depth of rainfall. Let's discuss the disadvantage of this method. The disadvantage is that we assume rainfall change linearly for drawing the isohyetes. For example, to draw isohyetes 10 between 8 and 13, we follow the linear change of rainfall over the distance like this. So this is the isohyetes 10. But this may be not true in nature. We can receive rainfall 10 in close to the 12. So here I complete 3 methods of average depth of rainfall analysis. In the next video, I will discuss about the other methods of rainfall analysis. Thank you.